here we have this fellow, and he essentially represents the ideas of the establishment. Okay, so it's good that he comes aboard and he throws garbage at me. I have no problem with that. I can handle it, believe me. And I like to answer these the issues that he raises, because there are issues that other people might question there and say, well, hold it, what about this about math? What about this about quantum mechanics? What about relativity, string theory, etc.? And this fellow raises those issues from the establishment's point of view. Whether he belongs to the establishment or not, I don't know. It's irrelevant. The issues he raises are all from the establishment. So let's address that. And we begin with science. Okay, science itself. What is science? What is science supposed to be? What is physics supposed to be? Okay, let's go with that first. And he says the following. Give me a second here. He says, Bill Gaede's rope hypothesis, thread theory, right, is a non-quantitative theory. It makes no quantitative predictions. Yeah, we don't do any quantitative and we don't do any predictions, okay? Because that's not what science is about. Quantitative and predictions have nothing to do with science. What is science? Science is rational explanations. That's our definition of science. You may not agree. You may say that's not what Newton and Galileo and all these guys from the 17th century came up with. Yeah, because they didn't have the slightest clue what science was. And here we are today. We can't answer a single question of quantum mechanics, of how the universe works at the micro level, at the macro level. Why? Because these people are still doing it the wrong way. We have the wrong people researching the questions that people want answered. Everybody out there and their mother, they want a qualitative explanation. And these people are saying, well, let me give you a quantitative description of what we measured and what we proved. And here's the equation. People don't care about any of that. People want to know why this pencil falls downwards. I don't need to know any math to explain that. And that's where the problem is. Right now, you have to go through the mathematicians who are the gatekeepers, and they say, I want to see your equation. I don't need any equation. I'm going to tell you what causes this pencil to fall to the floor. That's different than saying, at what rate is it falling? 9.8 meters per second squared? Who cares about that? I mean, that's something that concerns mathematicians, not the public. The public wants to know why the baby fell to the floor and why he didn't, go to the ceiling or stay in the midair. That's what they want to know. And so, yeah, this notion about quantitative and predictions and observations, gawking, drooling. Yeah, you can observe all day long and not understand anything. Does that make you a scientist because you observed? So, yeah, in science, we do not observe, we do not gawk, we do not make predictions, we do not use math because math are descriptions. We want explanations, rational explanations. And we don't care about predictions because, that's astrology. We need explanations. Explanations deal with the past. Predictions deal with the future. Science is about the past, not about the future. Science has to explain what happened, how it happened, why it happened, what caused it to happen, what the mechanism is. That's what science, as it relates to physics, is supposed to be about. Okay, so yeah, explanations have no use for quantities or predictions. It rejects how talking about me, he says that I reject how mathematics works. And that includes what is it? Models, predictions, tests. Well, we do use models, but not predictions or tests. We don't have any use for tests for experiments. Experiments are there to persuade people. Experiments are there to collect evidence and persuade the jury to believe like you do. It's got to do with belief. That's got to do with religion, not with science. In science, we do not attempt to persuade people, even though it's natural, human nature to do that, right? But the science part is the objective part, where you say, this is the mechanism I propose for this, for gravity, for magnetism, for electricity. That's science, okay? That's where it stops. Whether you believe one theory or another, whether they prove one to you or the other one, that's religion. That's got to do with, Sunday school, not with science. And so he said, and what I'm saying is, what's missing in mathematics is explanations. That's what's missing there. They don't have any explanations today for any phenomenon involving invisible, intangible mediators, gravity, light, magnetism, so on. He says replaces it with scientific definitions. He didn't use the word exactly those words, but I edited him a little bit. Of sine qua non terms such as object, exist, and touch. Yeah, physics is the science of existence. That word belongs exclusively to physics. Anyone using the word exist in any way, shape, or form has crossed the line into physics, whether they know it or not. And so when people say, well, I don't know if God exists. Does God exist? Well, I believe God exists. Well, I don't believe God exists. Well, maybe he exists. I don't know what tests we can run to prove that God exists. Very simple. You have to define the word exist. Once you define the word exist, you know whether God exists or not, or whether this chair exists or not. We have to define the word exist. No one has done so in the last 10,000 years. And so, he says, oh, Bill, you're redefining all these words. It's that they've never been defined. That's where the problem is. No one defined the word object in 10,000 years. No one knows what a thing is. And you can't do physics without an object, without a thing. And no one has defined it. And I'll prove that very easily to you. Let me convince you. Let me persuade you. Let me recruit you. Look for any textbook of physics, anyone at your leisure, and show me just one book on planet Earth that begins by defining the word object. I mean, if physics can't do without object, you would think that's the first word that should be defined on the first page of any textbook. And that's not what you see out there. You don't see the word object, you don't see the word exist defined. And so I had to define those words for the first time in human history. And that's why I reached different conclusions than all these bozos, clowns from science, so-called science, mathematics, mainstream. He says, Bill says that objects demand drawings. Well, if an object is that which has shape, which is our definition, the scientific definition of an object, of a thing, that which has shape, not that which you can touch, not that which you can see, because those are irrational definitions, right? It's that which has shape. All objects have shape. And if you know an object that doesn't have shape, please let me know, okay? But if it has shape, there should be no reason not to illustrate it. And you don't have to make a perfect drawing. We just need to get a ballpark figure of what you're talking about. There's a fellow was talking about the ether, and he was saying it was a thing. And I'm saying, okay, draw it. And he said, well, I can't draw it because I've never been outside of it to see it, and it doesn't have anything on the outside of it, and blah, blah, blah. All he had was excuses because he could not show me that, that ether was a thing that has shape. And so, we define these words, and that hurts a lot of people. And I have a saying that the word object, the definition of the word object, destroys all religions, especially all of mathematical physics, because mathematical physics does not have a single object. And you say, what kind of physics is that when you have no objects? What are you doing physics with? What are your mechanisms with? And they say, we do math. Oh, I thought you were doing physics. No, we do math. Okay, great. Okay, so he criticizes my point of view. He says, Bill says physics is explanation only. Absolutely. Observation, measurement, prediction, and experiment are not a part of science. Absolutely. Experiments are used only to persuade people and give them an idea that that you know what you're doing, that you know how to explain. It turns out there are no explanations in all of mathematical physics. And he says, why is it wrong? Without testable quantitative predictions, any story fits. And it turns out that with testable quantitative predictions, what do we have? We have the following stories, right? The story that he tells or that the establishment tells. Gravity is a warping of number lines. Oh, great. So looks like any story fits, right? Particle can be at two places at once, quantum mechanics. Earth drags time around itself. Gravity probe B, right? Self-creation of matter at the Big Bang. Yeah, like from what? How did the particles come into existence? And they say, well, we have virtual particles popping in from the void, coming into existence and out of existence constantly. Yeah, by what process? Explain the process, the mechanism. Okay, don't tell me that they do, tell me how they do it. Okay, and then planetary atom explains what? Ionization. Yeah, and that's what they use for electricity and quantum jump and all that stuff. So they have all these stories, any story fits, and that's exactly what we have today. So I don't think that measurement or predictions or any of that changed anything. We still have fantastic stories from the mathematical establishment. Nothing has changed. In fact, they're more fantastic than the Bible. I mean, the Bible talks about Jesus going to heaven, coming back, and so on. That's more believable than saying a particle can be in two places at once. I can't even imagine that. I can imagine Jesus going to heaven and coming back. I cannot imagine a particle at two places at once. So, yeah, I guess any story fits, right? Okay, so he accuses me of doing a little, I guess, word salad. Numbers can't push his rhetoric. Construes disagreement as semantics. Okay, so what do I have to say about Roderick and Samantha? Well, give me a second here. This is what I have to say about these two individuals. They're the ones who created all this nonsense, about all this language, this poppycock language that these people use. And so, yeah, I have a problem with it because, these individuals have filled the world with their jargon, carry a force, carry an interaction, transfer information. How do you transfer concepts? How do you carry a force? On the back? So they have all this language, This fellow today, in fact, we'll be talking about momentum, carrying momentum. How do you carry momentum? Momentum is already motion. How do you carry motion? How do you carry your run? How do you carry your swim? How do you carry your fly? Jesus. They have all this irrational language that they've created, and he complains about me saying, hey, Bill, you're changing the words. No kidding. Yeah, we got a problem with the language of mathematics. Okay? And so he says they don't do rational definition. What they do is operational, also known as functional definitions. And they look. This is what he says. Mathematics uses operational definitions. Yeah, that's what they do. And you look it up. An operational definition defines scientific concepts in terms of what? Of the operation used to prove them. So yeah, the guy waits till the end of the show to tell you what he talked about. So he mentions a word. He says, black hole is an object. He goes in there, talks 2 hours, and then at the end of the show says, well, an object is what I just explained. Oh, yeah, no kidding. What was it? I missed it. The way we do it in science, we define the words up front, the critical words up front, so that then people can follow the presentation. And these people say, no, wait till the end and you'll find out through the operational definition, through what we explained, what the definition was. So, yeah, operational definitions are irrational. And when you look at the Stanford Encyclopedia of Love of Wisdom, they call it philosophy, but you don't find the word philosophy defined in the Stanford Encyclopedia. And that should be the first word they should define. And again, it shows how the whole establishment is screwed up. If these people haven't defined the word philosophy, what kind of encyclopedia is the Stanford Encyclopedia of Philosophy? So yeah, it's love of wisdom. That's what philosophy is. And yeah, operationalism is based on the intuition that we do not know the meaning of a concept unless we have a method of measurement for it. Yeah, so it's nonsense. What these people have is absolute nonsense. They say we measure, and based on what we measure, that's the definition. Yeah, and that's how they ended up with particles at two places at once, and one particle entangled with another one affects it without any mediator. Yeah, sure. And that's how they also ended up with warp number lines. Okay, so he continues, he says, mathematical language avoids private semantics. Okay? Yeah, the definitions aren't private. They are introduced and anyone can challenge them and provide an alternative. Okay? So, anyone can present a definition. You don't like the definition, you had better have a better mousetrap, period. That's the way it is. Bill replaces mathematical definitions with what? Personal definitions. No, I replace them with rational scientific definitions. You don't like the definition? Again, all you have to do is challenge it and provide an alternative, a rational one. That means you're going to have to defend it. Okay? And what is a definition? A scientific definition. It's a limitation placed on the extent or usage of a word. Okay, so we had to define the word definition because people say, well, let me look it up in the dictionary. And what you find in the dictionary, definition is equal to meaning, and meaning is equal to definition. So they use these synonyms. Turns out that meaning is not a definition. Meaning is what the jury gets. Definition is what the prosecutor, issues. Okay? Prosecutors give definitions. The juror receives meaning. That's how it works. Okay, it's on the receiving end. Anyways, rational definition that can be used consistently, rationally, scientifically. That's a scientific definition. That's a rational definition. Okay, if you can use it in a consistent manner. Okay, and these people don't have that. They have, for example, just to put an example, light is both a particle and a wave packet. All three of them, all of the above. So which is the true mediator of light? And if you don't define the word object, you will never answer that question. A proponent of the scientific definition is required to defend his or her definition and show that it is rational. And you can't use any of these. Tradition, arguments of tradition, authority, or democracy. You can't say, well, everybody at the math club voted for it. Or that I got it from my teacher and he's an authority, he's got a Nobel Prize. Or this is the way we've always done it, it's in the dictionary and blah, blah, blah. You can't use any of those arguments. You have to defend your theory with something other than tradition, authority, or democracy. Okay? So you should be able to rationalize your definition. So don't tell me that my definition, or it's my private definition, my personal definition, or that you don't like my definition. You have to look at the definition and say what's irrational about it. Irrationality. For that, you need to define what rationality is. Another word that nobody's ever defined. No one knows what rational and irrational is. And again, it's on and on and on. We have to define all these words. Okay, so here he points out that my definition of object is shape. Okay, Bill's definition of object is that which has shape. Absolutely, every object in the universe has shape, and that's the only universal property of all objects. Okay. Physics cannot be explained without objects. You need an object to do physics. So it's the first word that a physicist needs to define. And it turns out that they have all these librarians, language majors, ontologists, philosophers, whatever they call themselves, right? And they're doing the definitions for physics. So the physicists say, hey, you want to know what an object is? Look it up in the dictionary. Yeah, who did the dictionary? Who wrote it in there? And it was one of these people who has no stake whatsoever in the word object. They could define anything in there. In fact, you have people like Russell, right? And Bertrand Russell. And he said any word that can fit into as a subject of a sentence. That was his notion of what an object is. And that's absolutely not true for physics. Okay, you can't put the word motion or the word orbit as a noun in physics. You cannot put it as a subject of the sentence, not formally. Okay, those are motions. Those are verbs, as far as we're concerned. And no one has ever defined the word object scientifically. So, it's like we're breaking new ground here. We have a new definition because there's never been a definition. We have the everyday definition, the definition we find in the dictionary, which is not scientific at all. Okay, and so, what you find in the dictionary are all irrational definitions. Not one of them meets the criterion of what science requires, that it can be used consistently, rationally, scientifically. Okay, it's because of that he thinks that field, the big word of mathematical physics, the two words, energy and field, but we're going to look at field first. Field is a concept, and he thinks it's a physical object. Yeah. And here it is, Bozo Joe, misconception. Fields are just numbers. Energy, momentum are concepts. Concepts can't push, okay? He says that's a misconception, all of those three. And he says fields are degrees of freedom. What is a degree of freedom? I mean, a degree of freedom is a physical object? Degrees of freedom is just, the amount of variables that you can vary, in whatever you're doing. It's got nothing to do with physics. Okay, he says fields are degrees of freedom in modern mathematics. Right? They carry what? Energy. How do you carry energy and momentum? How do you carry them? What kind of language is that? What kind of sense does it say to carry? And then it turns out that he believes that energy and momentum are physical objects. So he says he's carrying like you carry a rock. Okay, that's how he's using it in the sentence. Okay, that's what's objectively there, written. And he says fields, energy, momentum are physical. Field is the thing that pushes. And what is field? Right at the bottom says evaluate each location in space. That's what field is. Numbers. Okay, so how can numbers push? And he said, field is a stuff and not mere math. It pushes and pulls on charges, currents. And yeah, I don't know how you can push on charges and currents when charges and currents are concepts also. So all he's got is concepts. He's saying he carries energy and momentum, which are concepts, and then he pushes and pulls on charges and currents, which are also concepts. So these people are pushing concepts around all day long. Okay? And so he gives it his best shot at defining object. And he starts out by saying it's something. Something is the word we're trying to define. So you can't use the word something to define the word object. And it just shows that all these amateurs, they've never defined a single word in their life. They don't know how to define words. I mean, he doesn't even realize he's got a synonym there. What is a synonym? No definition at all. Okay? And he said, with localized degrees of freedom. What is degrees of freedom? Number of values that are free to vary. That's what it is. And all these, they carry concepts and act locally. I mean, what is this language? It's poppycock language. It's irrational language. All of mathematical physics has irrational language because they are using concepts as physical objects. That's the problem. And he says field as an object, a continuous physical medium in space-time. That's how he defines it. With degrees of freedom that carry energy and momentum. That's how he defines the word field. And, what is a degree of freedom? How can it carry energy and momentum? Well, you figure it out. Try to visualize what he's saying. Okay? Field configuration. He says it has shape. Bar magnet's field has a 3D geometry you can map. Absolutely not. Why can't you map it? I'll tell you why. Because, all fields, and take your pick. Gravitational, electric, magnetic. All of those, not by me, okay, by the way, okay, by the mathematicians out there, the people from Cambridge, the people from Harvard. They said they're all infinite. Fields are infinite. They go even beyond space-time, the edges of space. So we have a problem because he says the shape. He says, I can sprinkle iron filings over a magnet and you'll see the shape of the field. That's up to the strength where it can still, influence an iron filing. After that, the field continues. What don't continue are the iron filings because there's not enough strength to hold them. Okay, so something's holding the iron filings to the magnet. Okay, but the field, the so-called magnetic field, that's, don't look it up. Don't believe me. Look it up. Go ahead and you'll find out that all fields are infinite. Gravitational field, they reach to the other side of the universe, according to the mathematicians. I'm not saying that. They say that. Okay, so yeah, and so he has these notions that, field has shape, treats it like a physical object. It's not the only one that, the only concept that he's treating as an object. Here's a beam, okay? What is light? A propagating localized change in the electromagnetic field object. He puts the word object in there. So it's the electromagnetic field object. It's a thing, he says. And how does he justify it? He says, well, it has shape. Okay, why does it have shape? He says, a beam. A beam? What do you mean, a beam? There's no such thing as a beam. Beam is a concept. Okay, he's talking about a beam of light, has a cross-sectional shape and a longitudinal envelope, right? Wave packet, right? These are genuine 3D shapes of the field object. And what is a beam? Beam of light, you look it up, a visible or directional projection of what? Light energy. What is energy? A concept. We don't have any idea what energy is, or like Richard Feynman says, we have no idea what energy is. And he said, made up of many what? Parallel or converging rays. What's a ray? An idealized straight line that represents the path of light energy. And that word path there is very dangerous because, see, they use path as a double thing with double meaning. Path can mean the road or the car that's going along the road, the trajectory, the itinerary. So is path an itinerary or is it a highway? What is path? And see, they say represent the path, and it throws everybody off because people say, oh, it could mean this and it could mean that, or maybe it means both. The thing and the itinerary. And that's where the problem is. No, a ray of light, if it says it carries light energy or follows energy or whatever, then they're talking about motion. And so beam and ray, those two words are outside of, the object realm. They're not objects, so you can't say a beam. You can't use beam as a noun as a subject of a sentence in physics. Okay, so beam does not have shape. Aside from the fact that, again, how long is the beam? Please draw it. Okay, I want to see all around. Shape is all around, not in one direction only. Location. The beam, again, occupies a bounded region and has a set of distances to other objects. Absolutely not. Concepts don't have location. Okay, exists a shaped beam or a single photon wave packet, and there you have good old Roger Penrose, another clown, right? Wave packet. What is a wave packet? Well, it's that squiggly corkscrew that's what he put in his book. So I copied it from there, by the way. Okay, that's exactly what he put in there. Anyways, he says a shaped beam has shape. No, a beam is a concept. Cannot have shape if it's a concept. It carries momentum. Again, you have a concept that's carrying more concepts, right? And he said the object you can point at is the moving tube of energy momentum. So we have now tubes of energy, tubes of momentum. It's just unbelievable. These people are so far out there, they're not even in the ballpark. They don't even know what they're talking about anymore. If they think there are tubes of energy, tubes of momentum, what is he talking about? What is this language? It's a language for the asylum. That's what it is. Mental asylum. Okay, gaede. No one has ever explained attraction, and you need elongated contact object to pull. Absolutely. You cannot pull unless there's an elongated object. And he says interactions are what? Via fields. Yeah, because he uses this word field as a physical object. He says he's going to do the pull with fields. Okay, so not only does the field go outward when it's going outside your flashlight, light is two fields, electro and magnetic fields going outwards, but then he's got these fields also pulling somehow. The fields, I guess in, the number lines known as space-time. So you have these number lines and they're made of fields and you can pull on those fields and that's how you produce pull. See, that's how easy it is. Forces arise because the field configuration with the objects closer has lower energy. That's not an explanation, that's a description, but he doesn't understand the difference between a description and an explanation. The fact that you're telling me that it has lower energy, that's not the cause of pull. Okay, and he says the force is the gradient of that energy. Yeah, force and energy are not physical objects that you can use to explain how one object pulls on another. When the farmer pulls on a donkey, we call that force, we call it pull. That's what you have to explain. In this case, you're using a rope to pull on the donkey. What are you using to pull when you're using a word in mathematics? What's the mediator? We want to see a physical object. And he's using words such as force and energy. He says it's a gradient, or words lower energy. Yeah, so you have lower energy, and that's why it pulled, because we have lower energy. That sounds like, when they say that space-time, when the four number lines bend, that's gravity. Yeah, sure, bend the number lines, okay? So he says no action at a distance. Yeah, it's action at a distance as long as you use concept. You need to put a physical object. You have to draw it. You have to illustrate it, okay? Opposite poles approaching reduces field energy. Opposite poles? You mean positive against negative? North against south? What is this? A civil war of some kind? How does north pull on south? How does positive pull on negative? That's what you got to explain. What's the physical meaning of those terms? And he said the resulting force pulls them together. Yeah, I mean, you can explain anything when you use abstractions. We're talking about real objects. Put an object, a mediator. Then we can visualize what you're saying. You cannot say that positive attracts negative, north attracts south, or whatever. Oh, that's garbage, nonsense, poppycock. Okay, and where do you get all this stuff? Well, here's another boson in the establishment. His name is Sean Carroll. Okay, and he says we don't use particles in quantum anymore. We use fields. And let him tell you in his own words. Okay, I'm not going to put words in his mouth. Let him tell you with his own words that quantum is dead. Quantum means discrete particle, little ball. That's no longer true. Now they use fields for everything. What is a field? We don't know. It's a concept. And what is a particle? It's the vibration of field, which we don't know what it is. Okay, so listen to him. Okay, here it is. Give me a second here. Here it goes. Listen to him.
What do quantum fields in a vacuum look like? Empty space.
Just so like empty space. It's as empty as it can be.
But there's still a field. It's just
yeah.
What is nothing?
We now know that, the reality of our best way of understanding the world is through quantum fields, not through particles. So even the electron, not just gravity and electromagnetism, but even the electron and the quarks and so forth are really vibrations in quantum fields. So even empty space is full of vibrating quantum fields. And those quantum fields in empty space are entangled with each other. This location in space, there's a gravitational field, which I can detect
Yes.
by dropping something,
Yes.
right? I don't see it, but there it is.
Well, it would be a miracle. It would be a total miracle if he could see a field. I have trouble seeing concepts, quite a bit of trouble, in fact. So, yeah, this is where these people get the idea. They say, oh, it's a field. Oh, okay, that explains everything. Now we know it's a field. And here's another bozo. His name is Arvin Ash. And this clown says, fields are everywhere, everywhere, okay? Virtuals pop in and out of existence. Yeah, by what mechanism? Please explain. And so he has a field that vibrates and a little bump comes up. And he says, that's a real particle. Okay, what's the fake particle? Those are the virtual ones. Okay, so here goes. Listen to him. Let me get this guy out of there. Give me a second here. This is what he says about fields, okay? He says that fields exist, so please believe him. Listen to him.
In these turbulent seas, a large wave can be created. These are the real particles. The fields are always there and exist everywhere. Now, although they exist everywhere and you can't see them, they are not nothing. They're teeming with virtual particles. These are particle-antiparticle pairs that get created and destroyed. They come in and out of existence constantly.
That's not magic, right? They pop in and out of existence. I mean, how is this different than the old time religion, where they say, oh, the spirit came in and appeared and he talked to me and then he left. I mean, these people are doing religion. They're not doing science. None of that is science. That's why they say we can't find meaning in quantum. What's the underlying meaning? Of course they'll never find meaning because they're using concepts to represent, their physical interpretation. Their mechanisms are done all with concepts, with mathematical concepts. And they say, we understand it. Yeah, you understand it, but you have no meaning. That means you don't understand it. You can mathematize it. You can describe it mathematically. You give a name to that quantitative description, but that doesn't allow you to tell me what exists out there and how it works. And that's where the problem is, at the micro and macro level. Okay, what is it that these people need to do with fields? And here, let me give you an example here. This is what they have to do. This was what they were supposed to do all along, all the way beyond Faraday and some of these other gurus of science, alleged gurus of science. And here are fields. Okay, you have two wires. The one on the left, current is running into your eyes. Okay, and you can see the pattern is that's got that figure 8 in the center. And as you work out, finally you see the envelope. It just goes around both wires. Okay. How about the repulsion wires? Here you have one electricity in one wire coming to your eyes, the other one going away from your eyes. And when they're in opposite directions, you have this repulsion. And here you can see that the iron filings, when you sprinkle them on there, they have these patterns where it's like, I call it the two rollers of of one of those old washing machines where you put the whatever piece of cloth that you want to dry, you put it between them. You can see it's squeezing whatever goes between them. That's what those two things are doing. What I'm saying, these things are things in motion, which whatever you see there, those lines of force that are moving or moved at least at some point, the iron filings, those are sweeping around constantly. They're sweeping around. So this is my interpretation of that, what's really happening. Okay, there you see the figure 8s on the left-hand side, and you see the rollers of a washing machine on your right-hand side. And what you see here is that whatever's spinning around there is going clockwise on both wires, on the one on the left, and going clockwise and counterclockwise on the ones on the right. Okay, and so here's a summary of this thing. Okay, so that you can compare them. The ones on the top represent the two things going in the same direction, both clockwise, right? I got to do it the other way around for you to see it. Clockwise like that, right? And the other ones clash. They hit against each other and they're squeezing whatever's in there between them. Okay, that's what I'm saying. That's what you're staring at. That's what we see it. This is what we see. What we don't see is what's happening inside there in that region. Okay, and that's what we needed to identify all these centuries. Okay, and here it is. Okay, here you see it in motion. What the field is made of all these lines that are moving around, and we're saying it's the threads of the ropes that are foundation of our theory. And in the case of the clockwise and clockwise, the attraction, the one on the left, they're all moving in the same direction. And the reason they're attracting is that as one comes up, the other one comes down, and they interlock. They attach to each other slightly. Very tenuous friction, Mother Nature's friction, I call it, because it's at a level that we cannot even imagine. And gazillions of these threads are sweeping around. We're looking at them sideways, right? That's what's pulling the two wires together, electric wires together. Here on the other side, you have them going one in one direction, the other one in the other direction. Now the same threads are hitting against each other, pushing each other away. And that's the mechanism we propose. And people might say, well, where did you get this idea that, that there are things swinging around in there, some threads or whatever? They think those lines of force are just abstractions. It turns out the field they think is real. It's an object, but the real object, which are the threads that are moving around, they think those are concepts. They say, we just use them to explain, but they're not really there. And boy, they're wrong, completely wrong. It's the other way around. That's one issue. And here you see it. Good old Faraday said, I cannot conceive curved lines of force without the conditions of a physical existence in that intermediate space. He said those lines of force are real. Those are the real things, not the field. The field is a concept. And there we have good old Maxwell. He said, what is a field? The space in the neighborhood of electric and magnetic bodies. In that space, what? There is matter in motion. There's some exotic matter in motion that we cannot see or touch, but there is some matter in motion because it has an effect. It's not a field. You have to tell me what the field is made out of. Field is a concept. What's swinging around are the threads that make up that so-called region that everybody knows as field. And a word, by the way, invented by Faraday. Okay, and so here we have proof, evidence. Okay, here's, if you want to look it up, when you put a magnet underwater, you see that the iron filings are pulled up gradually. This is in very, very slow motion, okay? And you can see that they're being pulled up gradually over time, okay? Of course, this happens so fast in real time that you can't see it. It goes bloop, and all of a sudden, all the iron filings are around there. But when you film it in slow motion, you can see what's happening to the iron filings. They're being swept up by something that's swinging in that region. Those are the threads, not the field. The field is the whole thing. Okay, you can't say, oh, the field. The field is the entire thing. Okay, so again, you have to keep in mind the word field. The word field does not tell us anything. The word field is a concept evaluated at each point in space. And here's another example. And you see a spoon fall to the floor. Okay, and you say, well, why is it falling to the floor? Why is it not going to the ceiling or to the side or whatever? It falls to the floor. We call it gravity, right? And people say, well, yeah, it's gravity. Yeah, but gravity is what we're trying to explain. We need to explain what gravity is. Why is it falling to the floor? And here's just an analogy just so we put it in the right context, okay? Imagine a donkey falling towards a farmer. You would say, well, it's gravity. Yeah, but assuming gravity did not exist, how is the donkey approaching the farmer? You would have to explain why, when he moves his arms, the donkey is falling towards him. And you would think that there's some physical object that you cannot see. Okay, so maybe it's particles. Maybe the farmer's throwing particles at the donkey. Maybe he's doing this. Is that how he's attracting him, by throwing particles at it? I mean, is this how you would explain it? Or maybe it's he does it throwing waves at it. Okay, so he throws waves, gravitational waves, And that's how he pulls the donkey towards him. Or maybe you would think it's done like this with a rope. Now that seems more like it. Like, yeah, I can understand that. You pull on the donkey because there's something is physically attached to that donkey's neck. Then you can explain gravity. And you can see it on the left here. You can see that every atom of the spoon, when it falls, you don't see the connections, but here you see them. We made them visible for you. You can see why the spoon falls to the floor. Every atom of the spoon is bound to every atom on Earth. And as it falls, those ropes fan out. Those are the connections that connect any atom to any atom on the Earth, any atom of the spoon to any atom on the Earth. So that's why it falls. And we can understand it with some mediator. And we're saying it's a electromagnetic rope. Why electromagnetic rope? Because it resembles the wave, the transverse wave that these people have mathematized for so many centuries. Okay, final issue with our bozo clown here. He says, fields, energy, momentum are physical and measurable. No, we do not measure concepts. You cannot measure momentum. You cannot measure energy. You cannot measure fields. What is momentum? Well, it's that little P there, right? That's the symbol that they use for momentum. What is that equal to mathematically, right? Mass times velocity. What is mass? A concept. What is velocity? Another concept, a dynamic concept. Okay? So, you cannot measure concept. What you're measuring always is object. And this fellow never realized that. I mean, they don't teach him this kind of stuff at his monastery. So here, let's make sure we understand. Measure, you can only measure objects. You cannot measure concepts. It's irrational to say that you measured a concept. Here you have mass. Can you measure mass? No, what is it that you're measuring? You're measuring a physical object. The object, for example, let's assume you're going to put it on a scale, right? You put a rock on a scale, and you want to measure the mass, as they say. Well, you're not measuring the mass. You're measuring the rock, okay? The rock is what's pushing down on some kind of mechanism, spring-loaded maybe, right? And it gives you a value. And you say that value is the value of mass. Yeah, the result is the concept we call mass, okay? And again, really, that's not even true because mass is really the quantity of matter, so you cannot measure mass. You can only count atoms. Mass, if mass is quantity of matter, quantities we can only count, and it had better be integer values. Okay, you cannot say you're going to measure mass. And velocity, well, what is velocity? Can you measure velocity? Obviously not. Velocity is the outcome. It's the name we give to the final measurement. We don't say we measure velocity. What you measured is something else. You measured an object, right, that moved so much distance, for example, right? And what you're measuring, you use a standard. You say, well, the meter, and now you count how many meters. You say, okay, 5 meters. So the object moved 5 meters, and you make a calculation, arrive at velocity. But velocity is the result. You don't measure velocity. You measure objects, and the same with all of them. And then when you get to momentum, again, you're measuring mass and velocity. What have you measured? Well, you measured the rock that rolled, so many meters. Okay, and so you don't measure momentum. What you measured was a rock that moved. Okay, and we call the result momentum. It's a value. Okay, so no, and for that, yeah, you need to know the difference between an object and a concept. That's why we needed to define these words. That these people don't like that we redefine them. He says, no, they've never been defined. So we had to define them for the first time in a scientific manner. We cannot use the definitions we find in the dictionary. Okay, so that's the whole story on the measurement of concepts. You cannot measure concept. You can only measure. You can only measure out. You measure the table, not the length of the table. Length is what you got out of it after you measured the table. Okay, first you make a standard, you call it the meter. You measure 2 meters. Did you measure meters? Did you measure length? No, you measured table. Okay, let's get that right. Okay, we can only measure objects.